Hi, welcome everybody. I'm Asangwing, a student at the University of Maryland School of Public Health, and I'm also affiliated with the Global STEWARDS program. I'm here to talk to us about our drinking water. Very important. Don't we all like to turn our faucets and get a clean glass of water without worrying about waterborne pathogens? Water chlorination has been the cornerstone of drinking water treatment. Yet, over 7 million people each year fall sick drinking water, contaminated water from their faucets. Why is that? This is because chlorine-resistant pathogens can survive EPA's 4 parts per million chlorine concentration required to treat our drinking water. Putting that into perspective, you can be the one out of every 44 people who fall sick drinking contaminated water from their faucets. Therefore, we at the University of Maryland are researching a novel method, scalable, cost-effective technology, integrating germicidal UVC to completely sterilize drinking water and protect water safety. Thank you.
Hi, good afternoon everyone. My name is Gerry and I'm second year PhD student in epidemiology and biostats department, and I'm one of Global STEWARDS Fellow 2024. And today I will talk about my research briefly. So, as in 2019, we know that nearly 1 billion people live with mental disorders around the world. So we know how challenging it is. And recent IPCC reports state or say that in the future, mental health will keep getting worse. But little we know about the condition in Taiwan, like how people age, income, or even where they live will affect this condition. So that is where our works come in. We are looking at how people age, income, or other factors interact with climate and worsen the condition of mental health. And by sharing this evidence, we hope that we can create like a better life today and healthier community in the future. Thank you.
Hi, my name is Rafi. I'm a master's student here at UMD and I'm a Global STEWARDS. My work focuses on anaerobic digestion, a process where microbes break down organic matter such as dairy manure and animal waste into biogas that can produce renewable energy. Now here's the thing. In East Coast, dairy and animal process industry can generate up to 100,000 to 200,000 wastewater weekly, roughly about 2 to 4 swimming pools in your backyard. And this kind of wastewater can contain small amount of solids that can be recovered through a process called coagulations and produce energy. So my work focused on combining these small particles using iron-based coagulants and produce energy. We found that these kind of waste streams can produce enough energy to power up to 21 to 42 houses in Maryland. So yes, even your favorite chocolate ice cream can produce renewable energy that can power the grid. And now that's a sweet solution.
Hello everybody, my name is John Samura and I'm a second year master's student in the Agricultural Extension program, and I'm also a 2025 UMD Global STEWARDS Fellow. So come to think of it, of all the amounts of water available in the world, only 2.5% is available or is a fresh water, and this 22.5% is only available for all living organisms. And this is available for crop production systems, for energy production systems, and for household water use. And we also get to see constant increase in population. And with this constant increase in population, you would probably expect this resource to maybe increase, but that's not the case. In this case, not a single drop of water is being added to the water cycle. Rather, we get less and less amounts of water that completes the water cycle. And you know what that means, right? Because at the end of the day, if we get less and less water available, production systems such as agriculture will not be able to complete its cycle, and small amounts will be available, small amounts of food will be available to serve the increase in population. So in order for us to tackle this challenge, we have to find a way to find innovations that are cheap and that are also easier to be adopted by small-scale specialty crop farmers. But for us to be able to understand or to get these innovations being transferred to farmers, we have to understand the behavioral patterns of these farmers. such as the factors that influence their decision-making processes from the perspective of the farmer and from the perspective of the innovations as well. So therefore, my study, which focuses on socio-economic factors and that affect small-scale specialty crop farmers, is here to research and understand these behavioral patterns that influence small-scale specialty crop farmers to adopt rainwater harvesting systems within their cropping system. By understanding these factors, we will be able to tailor programs, extension programs that are geared towards improving or reducing the amount of water that is being used by small-scale specialty crop farmers, and also be able to develop policies that will encourage small-scale specialty farmers to adopt rainwater harvesting systems. Thank you.
Hello everyone, my name is Qingyue, a third-year PhD student from Nutrition and Food Science Department. In 2022, Maryland generated 1.5 million tons of food scraps. That's a mountain of leftovers. And compost can be the hero here, turning the trash into the treasure. And we don't know how the tiny microbes do the dirty work, and whether they might carry the antimicrobial resistance and affects food safety. Therefore, we are studying how they changing during the composting. So this process is not just green, but also safe and beneficial for the local communities. Don't stress over mass. Compost knows how to break it all down. Okay. Okay.